What I'd like to do now is explain what it is that we're doing with Predictive ROP. This is a feature that's new to ERA. It's not something that was in TAD, and there's a lot of blue sky in front of us as to where we can take this. But first I just need to explain what it is, how you turn it on, and some of the ways that you could use it. So if you remember back to our example where we've got a build and hold well trajectory, when we were entering information about the Earth, in the Earth Builder, we had to find the confined compressive strength as we get deeper and deeper and deeper in the overburden. Starting at 500 foot TVD, getting as deep as 8,000 foot TVD, we've kind of characterized the strength of the rock. It's getting progressively harder as we get deeper, although 9,000 PSI compressive strength is not terribly strong rock. All right, if we go to the 12¼ inch section, Predictive ROP only works when we're drilling. So we'll select a drilling sub-op. And I've predefined a few screens here: tension in the string, torque in the string, ECD, and standpipe pressure. This is a driller's view set of graphs. And at the moment, we have not activated Predictive ROP. If you notice in inputs, we're set to friction factor sensitivity. I've got 20,000 pounds weight on bit, 5,000 foot-pounds of bit torque, and we're drilling at 150 foot an hour with 120 RPM. Now, with these fixed assumptions, you can see that there's not a whole lot going on. We're not terribly sensitive to the friction factor. If I was to do sensitivity to weight on bit, you would notice that the torque curves and the tension curves will change. ECD and pump pressure curves do not change. Now on the tension plot, I've got the helical buckling limit drawn so we can see at what weight on bit what the tension at surface would be and whether or not we would start getting into a helically buckled state. And you notice for anything over 20,000 pounds actual weight on bit, we start touching the helical buckling line, and beyond that we've got quite a bit of buckling in the string. And that explains why our torque curve over here starts to go bonkers when we're operating with 40,000 pounds real weight on bit. That's not the point of the exercise here. What I really want to show you is how to turn on Predictive ROP. So if you go down to calculation options on the bottom of the screen and then select both reactive torque and predictive rate of penetration, close this box, you'll notice that the torque on bit and the rate of penetration boxes are now grayed out. Rather than having hard-coded values for bit torque and ROP, we're letting the model predict what the torque on bit and rate of penetration is using the confined compressive strength, the weight on bit that I've specified here, the rotary speed that I've specified here, as well as the bit aggressivity factor, or BAF. And in a separate video, we'll talk about the mechanics behind what BAF is, what it means, what equations are used to calculate it. But right now, just know that this BAF value characterizes the aggressiveness of the bit. With a more aggressive bit, we generate more torque for a given amount of weight. So you notice sensitivity to weight on bit. I've now got torque curves that are responding to the varying weight on bit. And if I would just scale over, scoot over on my plots, you'd notice that there is a rate of penetration plot, a torque on bit plot, and these are all predicted based on the inputs that I've chosen. And just watch what happens if I change the aggressivity factor. If I run a less aggressive bit, let's say the BAF factor is 100, hit enter, notice how the curves collapse. Run a more aggressive bit, say a BAF factor of 300, the curves expand. The other thing that's fun to play with is you could toy with rotary speed. So, okay, what if I'm going to turn the drill string rather, at 200 RPM? Notice the curves move to the right. It doesn't change the torque at the bit, but it does change the rate of penetration. If I slow the rotary down to say 10 RPM, well, I wouldn't be drilling very fast if I'm only turning 10 RPM. Now, the Predictive ROP model will also be impacted by whether or not we have a downhole motor. If I click on the builder and click on the advanced button and come on over to my library and say, all right, I'm going to add a downhole motor. I want to add a 9.5 inch motor. Let's just use this Baker low speed motor right here, 0.06 rev per gallon. It's not going to be turning terribly fast, but just to show you what happens. When I drag this onto the string, you'll notice that the rate of penetration is affected by the presence of this motor now. And to get a comparison, I can turn on ghost curves, and then we'll go back and remove the motor. I'll just scoot this down so you can see what happens when I remove the motor. Curves go away. Gray was the original case with the motor, and the dark bright curves are now without the motor. Notice that my pump pressure, you can also see the consequence of removing the motor or adding the motor, as it were. Turn off those ghost curves. So if we scroll on back, you'll notice that the ECD is also impacted by this predictive rate of penetration, because obviously our cuttings load is impacted by how fast we're drilling. Check sensitivity to RPM, sensitivity to weight, sensitivity to BAF. All of these things are different analysis that we can now do if we've got a calibrated model. And in a separate video, we'll walk through how you actually calibrate what the BAF is and confirm some of the assumptions that are going on behind the scenes. It's a fun toy to play with. It's really fun when you're in snapshot mode. If you lock the axes and you're operating with predictive ROP, the torque that's generated at the bit and the rate of penetration that we're drilling at will all vary as we get deeper and deeper due to the response from the different rocks that we drill through. As the rocks get harder, we don't generate as much torque at the bit. So scroll on over here to show us, I guess the torque is really, torque right here. You'll notice that the torque changes at depth. When I'm up here shallow, I generate a lot more torque with a given amount of weight of bit than I do when I'm down here at the bit itself. So interesting, fun stuff to play with. There's lots of different directions that this can go, and if you have any questions, just give us a shout.